Hi everyone, today's topic is on advanced glycation end product, or we often abbreviate them as AGES, and if you pronounce them as AGES. Okay, now there might be some confusion between glycation and glycosylation. The term glycosylation means it involves enzymatic addition of a carbohydrate moiety, and glycation means a non-enzymatic addition of carbohydrate residue. I have got a whole dedicated video for that. It's a very short video. You can have the concept clear. You can refer to that video. The title is, the link is in the description. You can find it in the I button. But today's discussion will be the advanced glycation end products. So there are few goals of this presentation. What are the goals of this presentation? This is to understand, to gain an insight regarding the formation of AGEs and their overall impact on diabetic patients and the ways how we can reduce or negate their effect. And to achieve this goal, we will divide the presentation into various subsections, which include definition of advanced glycation end products, the formation, how AGEs are formed. We will explain how the formation affects the diabetic patients, the primary sources of them, and how we can negate, once they are formed in the body, how we can negate their effect. So the working definition being, we can define AGEs as proteins or lipids that become glycated as a result of exposure to sugar. Now how they are formed? They can be formed both endogenously, that is in the body, as well as exogenously, that is outside in the nature. So in the body they happen mostly due to metabolism, normal metabolism and aging process, while in the exterior, that is in the environment, they are mainly formed due to cooking at high temperature. But both of these processes, especially in the body, is accelerated in presence of high blood glucose, that is hyperglycemia, which is observed typically in diabetes mellitus. Now let us look at the formation of the advanced glycation end product. There are three steps. Number one step, there is non-enzymatic reaction between the amine and reducing sugar, which makes it a Schiff base. In the next step, the Schiff base is converted to an Amadori product, and ultimately there are a series of slow chemical reaction which ultimately turn them into a irreversible advanced glycation end product. This is more or less the schematic reaction, right? And we can also visualize this in this reaction, which actually signifies more what is happening in vivo. Okay, so this is how it happens. The Schiff base is formed, it condenses to form Amadori product, and ultimately all of them condenses to form multiple advanced glycation end product. For example, furoyl furanyl imidazole, carboxymethyl lysine, carboxyethyl lysine, pentosidenine, imidazoline. What is golden mold? Glyoxal lysine dimer, methyl glyoxal lysine dimer, so on and so forth. We don't need to know the names or the structures in detail, unless we are definitely into drug development, where we need these ligands to form dockings, first of all in the artificial platform, then we can actually go in drug development. Anyway, moving along, what are the complications of AGEs in diabetic patient? We will look in general and we'll look into various systems. So we should know that these advanced glycation end products have got their dedicated receptor, that is known as RAGE, that is receptor for advanced glycation end product, that are normally present in low levels in the body. But definitely in diabetes mellitus, these are upregulated, and the interaction between the AGE and RAGE actually leads to the multiple micro and macrovascular complication. For example, in retinopathy, they can lead to a pericyte cell death, which will lead to an unprotected capillary, and then the complication of diabetic retinopathy, the flame-shaped hemorrhage, etc. will take place. Next, in VG, they can stimulate vascular endothelial growth factor, that will lead to vascular hyperpermeability. They lead to increased leukocyte adhesion, leading to inflammation, as well as platelet activation, leading to microthrombosis. So all these are the basic pathogenesis of diabetic retinopathy. In case of nephropathy, definitely AGEs alter the extracellular matrix biology, which leads to secretion of multiple chemokines, and they in turn activate the reactive oxygen, reactive nitrogen species, that is ROS system, and also they interact with renin angiotensin system to change the whole milieu of the kidney and ultimately leading to development of a parenchymal disorder. In case of diabetic neuropathy, the situation is almost similar. First, they can cause axonal degeneration and demyelination by interacting with multiple muscle protein and leading to excessive, impaired regeneration by altering the collagen types, especially in the basement membrane, right? And just like in diabetic nephropathy, they play a similar role in altering the extracellular matrix by synthesizing or triggering the release of multiple chemokines and ultimately activating the ROS via the NF kappa beta pathway. And this whole thing is actually triggered by the age-range interaction, which actually promotes the oxidative stress that can lead to a neurovascular damage. See, this is the figure which is showing the increased age-range interaction. The polyol pathway are opened up and NF kappa beta, that is the pro-oxidant genes, are transcribed, which can lead to increased secretion of pro-inflammatory cytokines and ultimately leading to neurovascular dysfunction. Anyway, so now we will look into the primary sources of advanced glycation end products. So we will first look into the exogenous sources, and we will see all the delicious stuff that we thrive in today's world, right, which we like to eat whenever we go out, or thanks to Swiggy and Zomato, we are ordering everything at home. So depending on what country, okay, Swiggy and Zomato might not be available where you are watching. It's an Indian exclusive one. So especially the browning technique, where we caramelize, we add sugar and high temperature, that leads to formation of advanced glycation and products, and 30% of these foodborne agents are absorbed when they are ingested. And in fact, the food companies, they add ages to induce color, to induce taste, because there's a dictum, what tastes good is not always, is actually bad, and whatever tastes bad is actually good for health. I find this especially in food. Anyway, next, smoking. Definitely it's one of the sources of pre-advanced glycation end products substances. So pre-ages are, the all amines are inhaled when cigarette smoke goes into our system, and smoking synergized with diabetes mellitus will definitely worsen the situation. So all complications of diabetes mellitus are much more accelerated in a patient who is smoker, and ages play a definite role, because pre-ages are there in tobacco smoke, that gives rise to formation of reactive and toxic advanced glycation end products. It doesn't stop there. You see, all the delicious stuffs added, which contains added sugar, that are rich in fructose and galactose, they also help in production of advanced glycation end products, because they are up 10 times fast metabolized than, they are undergo 10 times fast glycation compared to glucose. So they are very, very, very bad. You can see whipped cream, baked white bread, cold drink, chocolate syrup, chips, canned food, what not. Everything is bad. So what we are supposed to eat, right? We'll see what's good. Anyway, the primary source of ages for exogenous is done. Now, what are the endogenous source? How it is produced in the body? Normally, it takes place in our body through normal metabolism, okay, but the amount is very low, because in our body most of the blood sugar actually provides energy towards the body need, and a small portion of this is actually glycated to form advanced glycation end product in normal glucose. But in case of patients with diabetes, the formation is accelerated because there's an increased availability of glucose, either due to absence of insulin to utilize glucose, or due to insulin resistance. Whatever may be the cause, the amount of glucose availability is so high that most of this glucose get glycated to the precursors to form advanced glycation end product. And actually it is the low glucose concentration which can actually unhook the sugars from the amino compound and reduce the formation of advanced glycation end product. The equilibrium will shift, but once the irreversible ages are formed due to chronically high concentration of blood glucose, it's very bad and it will lead to problem. Therefore, we always suggest a patient, whenever diabetes is diagnosed early, get it treated, because it is the long standing diabetes that leads to devastating complication. If it is diagnosed and treated early, we all know life is good. So how can we reduce or negate the effect of advanced glycation end product? Number one, diet. Definitely we should actually avoid what is there. So we should reduce the intake of processed or pre-cooked food such as boxed food, frozen meals, all those salamis and sausages, absolutely no. Full fat dairy, no. Red meat, especially red meat, no. Fried oven, all those chicken tikka grill, absolutely not. Butter, mayo, cream cheese, no. So what's left? So-called all the not so much tasty food, if you ask a today's generation kid, right? So definitely intake of fish, it should not be fried or breaded, okay? Vegetable, fresh fruit, low fat dairy, legume, whole bread, boiled, poached, egg, stewed food, nuts, these are helpful. They will definitely lessen the formation of advanced glycation end product, and these are the food which are suggested to diabetes patient. The reason being these, they lower the formation of advanced glycation end product. So apart from food intervention, dietary intervention, what we can provide as a supplement, as a dietary supplement, we can provide alpha lipoic acid and acetylcysteine. These have been shown as an effective inhibitor of advanced glycation end products. Definitely they are in stages of animal study. Personally, I have worked upon a cocktail of alpha lipoic acid, alpha tocopherol and N-acetylcysteine, and I work in Alzheimer's disease. That is a whole different domain. But scientists, for example, D. Mattia, have explored the role of these compounds in a diabetic type 2 diabetes model using streptozotocin mice, and they have shown to reduce vascular complications. Next, benfotiamine. Okay, it's a derivative of vitamin B1, that is thiamine. It has shown to prevent inflammation caused by advanced glycation end product by shunting the glycolytic intermediate to the reductive pentose phosphate pathway. Studies have shown that administration of 1050 milligram of benfotiamine per day to type 2 diabetic patients, they reduce pro-inflammatory marker, they improve circulation. Also, they reduce the pro-atherosclerotic adhesion molecule, because advanced glycation end product helps in formation of foam cell and they trigger atherosclerosis. So definitely they help. If we reduce somehow the level of ages in the body, all those complications can be avoided. Next, L-carnosine. Multiple reviews regarding carnosine also has shown it to be a potent inhibitor for formation of ages, and it has also got a therapeutic potential in diabetes and diabetic complication. But the studies mostly are done in Korean and Chinese text, and basically they are non-existent in US literature. And you know, all the drugs are US FDA approved when we in case of Indian adoption. So it is not, nowadays it is not possible to pinpoint a dose. Might be there are clinicians who are much more updated than I am, but right now, as for my studies, still human studies are to be done in detail in order to pinpoint a definite dose, in order to find out a protective role. But what can be done is a cocktail of vitamin C and vitamin E. They have shown to prevent advanced glycation end product formation, and definitely human human trials have been done. But in case of human trial, the specific study by Conan et al. Involving 22 diabetic patients, of course the study was also very small, it needs to be validated statistically for 1 year. They didn't observe any reduction in ages in skin sample. So definitely there is potential, but it needs to be further explored. Now these were the dietary supplements. Now we are looking into specific drugs. What are the specific drugs that are aimed in reducing ages? Age breakers, ALT 771, 4,5-dimethyl 3-phenacetyl-thiazolium, right? Phenacylthiazolium. Okay, sorry for mispronouncing the drug. Anyway, so they help in breaking the advanced glycation end product protein cross link in vitro, in test tube. Okay, and they have shown to improve the arterial compliance in a phase 2 clinical trial in the elderly. So they have got a definite potential. Also aminoguanidine, how they prevent the formation of advanced glycation end product by reducing the derivatives of early glycation that are not bound to proteins. And we also know that hydrazine, okay, a derivative of aminoguanidine, is also a NOS inhibitor, right? And because it inhibits NOS, further generation of reactive nitrogen species and the oxidative stress can be reduced. That actually helps in formation of, that was actually helping in formation of ages, but it inhibits this process. Okay. Now, findings by Bolton et al. In a placebo RCT by type 1 diabetes patient using these drug has been shown to reduce the GFR. Okay, they have reduced the 24-hour protein excretion. Okay, these are the initial, I won't say initial, but these are the signs of diabetic kidney complication, right? However, the rise in serum creatinine that happens with diabetes, they didn't have any effect, right? Anyway, moving on. So these were the drugs that are not commonly used, right? I mean aminoguanidine and ALT-117. These are compound experimental molecules. But what is most commonly used in every diabetic patient who have got renal complication are antihypertensive, that is angiotensin converting enzyme inhibitors and angiotensin receptor blockers, ACEs and ARBs. And they have shown to have a synergistic effect along with anti-hyperglycemic agents, that is metformin, which is a biguanide. They synergistically scavenge ages, they help in reduction of age formation, and they have shown a significant promising role in improving the endothelial function in type 2 diabetic patients. Lastly, this is the last part of my presentation, metabolic reactivation therapy role. It is a unique therapy that has been patented by Dr. Thomas Aoki. It is practiced it was originally practiced by him. It was a chronic therapy to stop the advancement of diabetic complication or to control the hemoglobin A1s, that is glycated hemoglobin values, when all other therapeutic options have failed. Mind it will not reverse the tissue damage that has already occurred due to progression of disease, but it will stimulate the body in such a way so that no further complications are there. Okay, so it activates the cells in the liver and elsewhere to synthesize glucokinase and other insulin dependent enzyme with the delivery of insulin at a target level equal to that of a non-diabetic person of 200 to 1000 microunit per ml, and the higher level at the portal vein in conjunction with pulsatile function of 10 pulses per hour. So basically it's a insulin delivery system in vivo. The method I won't go into detail because it's his patent. Whatever I was able to get from his paper, I have highlighted the salient points. You are definitely more than welcome to read his paper in detail to get a more detailed understanding, and there are clinicians who can actually answer this question much better than I am. So it mimics the body's first phase of insulin secretion. It enhances the liver's processing of glucose and activating it to maintain the metabolic homeostasis, resulting in the tissues and organs that are being affected to reverse the effect of diabetes. So better availability of glucose, because in diabetes glucose is high but it is not available either due to lack of insulin or due to a downregulation of insulin receptors, and hence glucose is recognized as an alternate source of energy and is used less it uses less oxygen for its utilization. Okay, which in turn allows the tissues with decreased circulation. Mind it, in diabetes where the tissues are already damaged, the vasa viscerum has been already damaged. So because in diabetes the end organs, end arteries are damaged. So, but in this case the tissues which already have a decreased circulation to function, they can actually function with less demand for oxygen, resulting in normal functioning, damaged repair and healing. Mind it, diabetes is a positive feedback reaction. I can say that once it starts to damage, the damage goes on and it slowly increases. This metabolic reactivation therapy actually can prevent that. Anyway, so to conclude my study, the formation of advanced glycation end product is a contributing factor that that aids in the complication that are found in diabetes mellitus. The formation of ages in diabetes occurs as a consequence of chronically elevated blood glucose levels, and primary sources of ages should be avoided or limited if possible, especially if it is a dietary intake. It should be avoided, and it leads to blood vessel inflammation, oxidation of bad cholesterol, leading to increased atherosclerosis. We have discussed that. Dietary modification is strongly recommended to reduce the effect of ages in all patients. Next, we discuss about dietary supplements that are beneficial in either improving or preventing the effects of ages in diabetic patient. However, studies are limited to small size in human and only animal studies, and lack of studies are an area which can be explored by scientists and doctors who would like to work in animal models and clinical trials. Next, the investigation of pharmacological agents, specially aiming at ages. They include age breakers and inhibitors, common pharmacological agents like angiotensin converting enzyme inhibitors and angiotensin receptor blockers, and metformin, that is antihypertensive and antihyperglycemics. They have shown a promising role. And lastly, more advanced, that is metabolic activation therapy, may have its advantage with reducing the effects of ages by allowing tissues with decreased circulation to function with less demand of oxygen, which I told you, resulting in normal functioning, damage repair and healing through activation and of diabetic patient metabolism by directly burning glucose. So these are my references, and I thank you for your patient hearing, and feel free to get back to me in the comment section with any queries that you have. I'll be more than happy to make a dedicated video, because in this video it was just possible to include all the highlights so that I can cover the topic as a whole. Each and every subtopic can be covered in detail. So if you are interested, please let me know. I'll be more than happy to make a video on that. I'll see you soon with another video. Till then, bye and take care.